Hello everyone, welcome to Video for Sure. Today we're going to see about introduction to matrices. So let's start. So in this lecture, we are going to see introduction to the matrices, what is matrices, type of matrices, why do we use matrices, and all the concepts that are used in the matrices or that are based on the matrices. We're going to see linear equation and how to find rank and trace of a matrix. So we're going to see all this thing in this lecture. So let's start. So as you can see here, matrices actually means a rectangular array of m cross n rows and column. What do you mean by this? It's look like this, as you can see on my screen. It's a rectangular array of mn element. Mn element means when you multiply this m into n, means m rows, m number of rows and n number of column, you will get the number of element. For example, here you can see matrix of order 3 cross 2. 3 here stand for row and 2 here stand for column. As you can see here, 3 rows are there and 3 columns, 2 columns are there. And here A1, B1, A2, B2, A3, B3 are what? They are element. They are the element of this matrix. So here, when you multiply 3 into 2, how much we get? 6, right? So here, you will also get the sixth element. So here, a matrix means it's a rectangular array of mn element, m into n element, arranged in m cross n fashion. Arrange in m cross n fashion means arrange in the form of m number of row, m number of row. So here m row n column means it will give you the total element m into n column. So in Python order we call as a shape of matrix. So in Python we say is as a order of matrix, or the order of matrices is this one: 3 cross 2. 3 is your row and 2 is your column. So the element of matrices are usually written in this bracket, and this A1, B1, A2, B2 are the element which can be 1, 2, 3 numeric element. Similarly, the matrix of order 4 cross 3 will have how much total element? It will have total element will be equal to 12. 4 into 3 will become 12. So you can see here there are 4 rows are there. 4 rows, 1, 2, 3 and 4, and we have a 3 column. So matrix is a rectangular array where elements are arranged based on the m cross n order, and when you multiply those m into n, you will get the total element here. Similarly, here also you will get the same. So this is called matrix, and we call it as a shape of a matrix. So there are different kind of matrices are there. Equivalent matrices. Equivalent matrices, it means that their shape and order are same. What do you mean by this? Suppose here you have a matrix A of order 2 cross 2. What do you mean? Means you have a 2 rows and 2 column. Row is here 2 and column is here 2. 2 rows and 2 column. Similarly, there is one more matrix are there whose order is 2 cross, whose order is 2 cross 2, where you have a same row is equal to 2 and column is equal to 2, then this is called as a equivalent matrix, equivalent matrices, because they both are having same order 2 cross 2 and they are having the total number of element also same. So total element TE I am writing here, which means total element equal to 4, right? When you multiply 2 into 2, you will get 4. Similarly, here also, when you multiply 2 into 2, you will get 4. So this is called equivalent matrices, where the number of elements are same and order is same. Let's see about the another one. Equal matrix means which are exactly same, which are exactly equal, means their element are also same. For example, suppose you have a element where, suppose this is a name of a matrix A, which is of 2 cross 2 order, and you have a element like 1, 2, 5, and 6. Similarly, you have one more matrix whose name is C, and it is also of order 2 cross 2, and it is having an element, suppose 3, 4, 9, and 6. And I'm also enclosing this as a bracket, and it is also 2 cross 2, right? So here, this is called equivalent matrix, but this is not called equal matrix. Why? Because here the size are same, but element are different. I repeat once again, here size are same, but element are different. So this is not equal matrix. Equal matrix means where element will also be going to be same. So let me rub this and show you. So now this is called equal matrix where corresponding element are same. Here you can see 1, this is also 1, this is 2, this is also 2, this is 5, this is also 5, 6, and this is 6. Order are also same. So we can call this as a equal matrix where element will remain same. Order is also same, 2 cross 2. So this is called equal matrix or equal matrices. Now, what do you mean by rectangular matrix? A matrix of order m cross n is said to be rectangular matrix where the number of rows is not equal to number of column, where the number of rows is not equal to column. This is a not equal to symbol. So a matrix of order m cross n is said to be a rectangular matrix where the number of rows is not equal to number of column, and the matrix is called square matrix when the number of rows is equal to number of column. If you see in the previous example here, I have given for equivalent matrix and equal matrices, I took 2 cross 2, right? So 2 cross 2 will be the example of your square matrix because there the number of rows and column are same. And for rectangular matrix, it can be anything where the number of rows is not equal to column, like 3 cross 4, 4 cross 3, right? where the number of rows and column will not be same, that are called as a rectangular matrix, and a square matrix where the number of rows and column are same, m equal to n, where this m is for rows, n is for column, m is for row, and n is for column. So this is called 2 cross 2 is called square matrix, and this is called rectangular matrix where the number of row value and the column value is not equal to same, then it is called rectangular matrix. A row matrix is where you have only single row. It means that how it is look like. Let me show you. This is called as a row matrix where you have only single row. This is only single row you have, right? So this is called a row matrix where you have only single row, and same for column matrix where you have only one column. So column matrix will be look like this, where you have like this. It is horizontal. In case of column, it will be only single column. So it will be look like this. However, the element may varies. Element can be anything. So element may can vary here. So this is row matrix and column matrix where you have only single column. Null matrix or zero matrix where all the element are zero is your null matrix or zero matrix. And your null matrix or zero matrix is represented with O. You can see here it is represented as a O, which means that all the element will be zero in that matrix or null values are there. So these are the type of matrices. There are a few more matrices, diagonal matrices. What do you mean by diagonal matrices? Diagonal matrices will have all the non-zero element on the principal diagonal. What do you mean by principal diagonal? Diagonal element means this one, which is present in the diagonal, which is present in the diagonal. So here, the diagonal element means, or diagonal matrix says, or we can say diagonal matrix, where the diagonal matrix element will be non-zero. Means in diagonal, you should not have zero values. So in diagonal matrix, you have a non-zero element in the diagonal. And how we represent the diagonal? So this is your diagonal of your matrix for 2 cross 2 because it is having 2 rows and 2 columns, and it is 3 cross 3. So the diagonal element for 2 cross 2 is this one, which is a non-zero element, and diagonal element for this matrix 3 cross 3, where you have a 3 row and 3 column, will be this one. So diagonal matrix means where the diagonal element will be your non-zero, whereas other element will be your zero. So here you can see I have make a round here, which is your diagonal element, and it is non-zero. Other element are zero, you can see here. Similarly, here also the diagonal element is non-zero, and other element are 0. And this is a matrix of 3 cross 3 because of 3 rows and 3 column, and it is 2 cross 2. Scalar matrix means where all the diagonal element will be same and non-zero. So here you can see the diagonal element are same here, 4 and 4, and here also the diagonal element all are same. So scalar matrix is one where all the element are non-zero and they are same, as you can see here. So here the diagonal element are same and they are non-zero, so they are called as a scalar matrix. Where the diagonal element are non-zero element but not mandatory to be same, they are called as a diagonal matrix. So now, what do you mean by unit matrix or identity matrix? A unit matrix or identity matrix means where the diagonal element are 1, where all the diagonal element are 1, they are called as a unit matrix or identity matrix. Here, this matrix of order 2 cos 2, where you can see the diagonal element are 1. Similarly, this is 4 cross 4, where the diagonal element are 1. So this is called as a unit matrix and identity matrix, and it is denoted by I, and this is called principal diagonal, means where the diagonal element all are 1. So here the unit matrix of order 2 cross 2, and this is 4 cross 4. Now, what do you mean by transpose of a matrix? Transpose of matrix is very easy. It is just converting your rows into columns. Here you can see this is your row. So this is of how, what is an order of this matrix? How many rows you have? 3 rows. And how many columns? 2 columns. So when you will going to transpose it, you will either represent with this symbol or T symbol, and you will going to convert all the rows into column. Means this row will become column AB, CD which is a row here will become column, EF which is a row here will become column here. So here this 3 cross 2, which means 3 row and 2 column, will now convert into 2 cross 3, which is 2 rows and 3 column. So transpose of matrix is nothing but just converting all the rows to the column. So here, as I said, transpose of matrix means converting all the rows to the column. So when you convert all the rows here to column, it will become transpose of the matrix. Here, as I given you example, this is 3 cross 2, 3 rows here and 2 column. When you do the transpose of it, it will become 2 rows and 3 column. So this is called the transpose of matrix. Now here we are going to see how we can perform arithmetic operation on the matrices. So here you can see I have a one matrix here A, which is having this element A1, B1, C1, A2, B2, C2. Similarly, I have another element B, another matrix B, which is having this element. So how we're going to perform arithmetic operation on this? So let's see that. So here, when you want to do addition of two matrices, always remember the addition will be going to perform between the same order matrix. Here, the order of this matrix is 2 cross 3, and this is also 2 cross 3. So now when you are going to do the addition or subtraction, always remember the mathematical operation will be going to perform only the addition and subtraction will going to perform when you have a same order. When you have a same order of the matrix, then only we're going to do the arithmetic operation here, addition and subtraction. So here, how you can do the addition? A1 plus C1, B1 plus D1. So element wise, you are going to do addition. C1 plus E1, A2 plus C2, B2 plus D2, C2 plus E2. So like this, you are going to do addition. Similarly, you are going to do subtraction. A minus B means you are going to subtract B from A. So how you are going to write? A1 minus C1, B1 minus D1. Element So element wise, you will going to do the subtraction here. A1 minus C1, B1 minus D1. So let's see one example here. Now here, this is one matrix of 2 cross 2, 2 rows and 2 columns, having a name P, and this is one matrix Q, which is again same 2 cross 2. Now I want to do addition between these two. How we're going to do that? 5 plus 6, element wise we're going to do. 5 plus 6 will become 11. 4 plus 3 will become 7. 6 plus 2 will become 8. And 3 plus 1 will become 4. So see here, Your matrix is also 2 cross 2, and your output is also 2 cross 2, right? So this is way of doing arithmetic operation. Your matrix will also need to be in a same order as your output also. So here you can see input is of 2 cross 2. So output also I'm getting 2 cross 2 here only. So this is mandatory to be having a same order 2 cross 2. So as you can see, this is 2 cross 2. This is also 2 cross 2, 2 rows and 2 columns. And when I will going to do the addition, element wise, we're going to do addition and we will get this operation. Similarly, when we going to do the subtraction, how we're going to do the subtraction? Let's see that. So as I said you, element wise, we're going to do the subtraction when we want to do P minus Q. So we're going to subtract Q element from P, right? We're going to subtract Q element from P. So how we'll get the output? 5 minus 6, we will get minus 1. 4 minus 3, we will get 1. 6 minus 2, we will get 4. And 3 minus 1 will get 2. So here you can see here A1, C1. So you can compare like 5 minus 6 will be minus 1. 4 minus 3 will become 1. 6 minus 2 will become 4. And 3 minus 1 will become 2. So we are getting the output in a same order as input. So like this, we have to perform addition and subtraction in matrix or any matrices. Similarly, P, when we did the addition also between P and Q, we did like this. 5 plus 6 will become 11. 4 plus 3 will become 7. 6 plus 2 will become 8. And 3 plus 1 will become 4. So I hope it is clear to you what is matrix, type of matrix, and the addition and subtraction operation in matrices. So I hope you found this session informative, and we're going to meet in our next session with some more detail about this matrices. Till then, bye.